So the next question is, what is CoAP? Draw CoAP message format. Also compare CoAP and MQTT. It is asked for 10 marks from the question paper Feb-March 2022. Okay, so we can divide the question into three parts. One is what is CoAP, then the message format for CoAP, and then you have to compare CoAP and MQTT. So approximately, if we can divide the marks, we can give what is CoAP 2 marks, then message format we can give 4. Remaining 4 marks will go for your comparison of your CoAP and MQTT. Okay, so primarily what is meant by CoAP? CoAP stands for Constrained Application Protocol. So Constrained Application Protocol resulted from IETF, which is nothing but Internet Engineering Task Force RESTful Environment, that is Constrained RESTful Environment, that is CORE. So RESTful, you know that representational state transfer application programming interface. API is nothing but your application programming interface. Working groups efforts to develop a generic framework for resource-oriented applications targeting main point is constrained nodes and networks. So what is meant by CoAP? It is nothing but an application, as the name indicates, it is nothing but an application layer protocol that operates with the constrained nodes and network. The CoAP framework defines simple and flexible ways to manipulate sensors and actuators for data or device management. The CoAP messaging model is primarily designed to facilitate the exchange of messages over UDP. So what is UDP? User Datagram Protocol, which is nothing but a connectionless service, right? Including the Secure Transfer Protocol or DTLS, Datagram Transport Layer Security. So let us move on to your message format. The CoAP message is composed of primarily four main fields. One is your short length fixed header, which is fixed header length. So it is fixed for 4 bytes. Second is your variable length but mandatory token field. So the second main part is your token field, which is a variable length, but it is mandatory. So it is variable length, that is 0 to 8 bytes. Third is your option field, if necessary, it's optional, and the payload field. Okay, so mainly it is divided into 4 major parts. Okay. So moving on to the message format, as mentioned, mainly 4 parts you have. So the first main upper layer consists of your header field, which is 4 bytes, that is your fixed length header field, right? So it consists of VER, which stands for version, T which stands for type, token length, TKL stands for token length. Next is your code and your message ID. Okay, so you have 1, 2, 3, 4, 5 fields. The total number of bytes fixed size fixed bytes of 4 bytes. The next layer consists of your token, which is the variable length. So what is the length? It is 0 to 8 bytes. Okay, and the third one is your option field, which is optional, and the final, that is the lowest layer, is nothing but your payload field. Payload is nothing but your actual data which you are transmitting, which is also an optional. So in order to identify whether it is a payload or a data or information, we have a 8 bit data in order to identify whether it is a payload or your payload, that is your data. Okay, so now let us see one by one separately. So the different fields are, for example, version, type, token length, code, and message ID comes under your header, right? So whereas your first field, that is your version field, identifies the CoAP version, and the second one is your type. Mainly there are 4 types. So first one is conformable, which stands for CON. Second one is your non-conformable, which stands for NON, and the third one is your acknowledgement, and the fourth one is your reset. Okay, conformable, non-conformable, acknowledgement, and your reset. These are the 4 different types. Now your types of your message. Now the next one is your token length. So this token length is nothing but which gives the length of your token, that is your next layer field. So token length, which specifies, which is normally 0 to 8 bytes of the token field of this token field, right? Next one is your code. It you know that it is the request method, right? Indicates the code indicates the request method for a request message and a response code for a response message. That is, you know that CoAP is a request response type of protocol. Request response type of your protocol, whereas your MQTT is a publisher subscriber type of protocol. Okay, so this code indicates the request method for a request message and a response code for a response message. Now the next field is your message ID. So it detects if there is any replication or duplication, and it is used to match the acknowledgement and reset message types to conformable and non-conformable message type. Mainly it detects the redundancy or your message duplication. The next layer is nothing but your token field, which with a specified length specified by your token length, that is nothing but 0 to 8 bytes, that correlates the request and responses. Next one is your option field. It specifies the option number, length, and option value. Capabilities provided by the option field include specifying the target resource of a request and proxy functions. The last one is nothing but your payload or your data. It carries the CoAP application data. This field is optional. So, but when it is present, a single byte of all precedes the payload. That's what I have told you. You have 8 bits, right? 1, 2, 3, 5, 6, 7, 8. 8 bits of data to identify whether it's the beginning. The purpose of this byte is to delineate the end of the options field and the beginning of the payload to indicate that you have a payload. So moving on to the last part, you are going to compare your CoAP and your MQTT. So what is MQTT? Message Queuing Telemetry Transport. Okay, so we have taken some of the important factors, and we are seeing the characteristics of your CoAP as well as your MQTT. It has to be given in a table format. So what are the different factors? So the first factor is main transport protocol. What is the main transport protocol used in your CoAP? It is built over your UDP, that is your user datagram protocol, which is a connectionless. Okay, and MQTT, it is the main transport protocol here is your TCP, that is nothing but your transmission control protocol, which is a connection oriented protocol. Now, typical messaging, what is your messaging? I have told already. CoAP is the request response type of messaging, whereas your MQTT is a publish subscribe type of messaging. Effectiveness of your LLN. So what is your LLN? Low power and lossy networks. So CoAP works well, that is excellent in your LLN network, whereas it is not so efficient. MQTT is low or fair effectiveness in LLN networks. Now, what is your communication model? Communication model for CoAP, it is one-to-one communication model, whereas in the case of MQTT, it is SSL or TLS. So SSL, what is SSL? SSL stands for Secure Socket Layer, and your TLS stands for Transport Layer Security Protocol. Okay, and strengths, what are the different strengths of your CoAP and MQTT? For CoAP, it is a lightweight and fast with low overhead, right? Low overhead and suitable for, mainly it is suitable for your constrained networks. Then it uses a RESTful model that is easy to pass and process for constrained devices. It supports multicasting, that is one to many, right? Both asynchronous as well as synchronous messages. But whereas in the case of MQTT, what are the strengths of your MQTT? It is a TCP. TCP and multiple QoS option provide robust communication, simple management and scalability using a broker architecture. Now, what are the weakness of your CoAP? It is not reliable as TCP based MQTT. So the application must ensure the reliability. Whereas in the case of MQTT, what are the different weakness of your MQTT? It has higher overhead for constrained devices and networks. TCP connections can drain low power devices, and it doesn't support any multicasting. Okay, so these are the different points you can write. First, you can write what is meant by CoAP, followed by the message format, and followed by the comparison of your CoAP and MQTT.